Hello everyone, welcome to Ketaki Tech. In the last session, we have seen what is a quick start with the Kubernetes. So this is a very now in this session it's a very important topic. The components of Kubernetes. Those two are control plane nodes and worker nodes. We'll try to understand what is control plane node and nodes and worker nodes. So before going further in detail with the worker nodes and control plane nodes, I just wanted to give more about K8s orchestration, the usage of the Kubernetes. So when you say what is the main usage of the Kubernetes, so whenever you are deploying your application and handing over to the Kubernetes will manage your application. The application in the sense it can be it can be multiple services. It's a best example when there is a consider the example of playing football. If there is a coach for football playing and with coach and without coach, if there is a coach, all the players will be well organized and well planned, and the coach will be having the rules and regulations that each player has to follow, and it will go properly. And if, for example, if there is no coach in football game, then what happens, there will not be any rules and regulations, and all the players will be grouped together, and there is no the proper maintenance of the players, and the match also it will not be good. So the same way, when as how the coach will manage the players and rules and regulations, the Kubernetes will manages your all microservices. Here the players, you can consider it as a microservices. So those microservices, once you deploy, the Kubernetes will be well managed by the all the your applications or microservices will be well managed by the Kubernetes. So that's why we call it as a orchestration. So another best example, when you are deploying your applications or microservices to the Kubernetes, it's you can compare with the post. That means whenever you are sending some document or any product to one place to other place, what you will do, you will post it. You will just enter the address to that courier or on a cover, right? So the remaining you will no need to worry about how that it will reach to the destination, whatever the address you mentioned to the your product. So the post person or the department, post department, can take your product, it can reach, it can make your product to reach to the destination based upon your address. You no need to worry how they will take care, like how they will move your product to one place to other place, whether they will use four-wheeler or two-wheeler, or they will go via train or aeroplane. That you no need to worry, but your product will reach to the destination. The same way, whenever you are deploying your application, you no need to worry what is the CPU size, what is the memory of the system, or how it will be running, and how the your microservices are will be managed. So it's not no need to worry. You just what you need to do, you can just design your application as a small independent microservices in your favorite language. Say you develop your application in a .NET or Java or any technology which you know. Once you implement a application, maybe you can implement all your applications in part of microservices. That means all pieces of microservices. In the previous session, we have seen what is microservices, how it will be designed. So once you develop your independent microservices in your favorite language, package each microservices as its own container. You just make it the container, use the Docker to create a container, or you make the package as an image, you create it your each microservices, then wrap each container in a Kubernetes pod. We will see in details what is Kubernetes pod in upcoming sessions. So then what you will do, you deploy your pods to the cluster via higher level controllers such as deployment, stateful set, etc. Now you may be worrying about what is pod, what is cluster, and what is node. We'll see in great details. But before going to the cluster and before going to the control plane and worker nodes, you should be very clear with the Kubernetes orchestrator. So it will manages your application, it will manages your all your services in a better way. So I have given an example of the coach who is managing all the players with rules and regulations in a football match. So this is little bit theory. We will now in detail we will go what is the control plane and all. So now coming to the Kubernetes as a cluster. So now what is cluster? Say you have an operating system, maybe you can consider your your lower environment, or you can consider cloud. So what you will do whenever you are installing the Kubernetes there, it will create a cluster. So whenever you are installing a Kubernetes, either in your laptop or either in your any other servers, or it may be in the cloud, AWS or Azure, when you are installing your, whenever you are purchasing the Kubernetes, that is nothing but a cluster. It's an empty cluster. So what we will do inside an empty cluster, we will we will put some other machines like virtual machines or physical machines, or it can be anything. Okay, so that means when you want to deploy your application, there should be some one machine, right? Then only your application can run. For example, you implemented your application in a .NET or Java. To run that application, it requires a operating system. That means it requires a machine. That machine it present inside the Kubernetes cluster. So K8s cluster, that cluster is it will be having a bunch of machines. Keep it in a mind. The cluster is having a bunch of machines to host your application. Without the machine, your application can't run. So that is the very important point you need to remember. So that means once you install the Kubernetes, empty Kubernetes, there you will be adding bunch of machines to host your applications. So when if you want to run your application, the machine is required. That machine we will call it as a node. We call machines as a nodes. That machine can be virtual machine, physical server, or cloud instances, or anything. So you have the Kubernetes cluster. Inside you will be having the bunch of machines. That machines are responsible to run your applications. So now when you are adding the machines into the Kubernetes, maybe virtual machines or physical servers or cloud instances, those machines we will divide it into multiple components. So one is control plane and another one is worker nodes, control planes and worker nodes. So these two are very important components of the Kubernetes. One should understand very well to go further in details of the Kubernetes. So K8s cluster, you are install the Kubernetes. In that, what I am doing is we are going to add some virtual machines. We call it as a node. So those nodes we are making two parts. One is control plane node, one is control plane node, and another one is worker nodes. So now the question is, when you implement your application or microservices, whether you run the in this machine control plane machine or worker machine or worker nodes. So that you will get to know in upcoming session, upcoming slides. So when you say control plane and worker nodes in a Kubernetes, this is a very good example. What is control plane and worker node? See, control plane also a machine and worker nodes also a machine. I told node is nothing but a machine. So this consider the human body, its cluster. Inside cluster, I am going to install one virtual machine, that is a control plane, and multiple machines, those we call it as a worker nodes. So what you will do, you will be running your application not in this control plane, rather you will be running your application inside a worker nodes or worker machines. Now if you imagine the why I am calling this head as a control plane, so that means head is it manages all your parts of the body. That means to run, to walk, to do jumps and all. So your control, your head will manage all the operations of your body. The same thing, control plane machine will manage all the worker nodes. That means control plane machine manages all the other machines, that means all other nodes, and like that. So that's why we call it as a control plane, that head of the body, and worker nodes all other parts of the body. This is a very good example you can compare with the control node and worker nodes. So again, there are some parts we will be having under control plane and worker nodes. So what are those? Inside a control plane, that means inside a head. So to manage all your body parts inside a brain, you will be having like different parts, right? So like that, in control plane also we have multiple, again, services. We will call it as a services. What are those? API server, scheduler, controllers, and cluster store. These four are the very important components under control plane. So what you will do, this is again a control plane, also a one node, or we can call it as a one machine. So in that we have these four parts. When you are tagging any machine or virtual machine to the control plane as a control plane node, then it will create all four services. How to map your virtual machine to the control plane, that we can see in a upcoming sessions. So now we'll try to understand in more details what is API server, scheduler, cluster store, and the controllers. All above four services making up the controller plane. All these services run on each control plane. That means there is no hardened role, there is only one control plane in the Kubernetes. There may be multiple control planes might be there. It will be in the odd numbers, 1, 3, 5, like that. So whenever you are installing, attaching your virtual machine to the control plane, that will be definitely will be have all these four services. It's also good practice not to run user applications in a control plane. So your applications will be running under the worker nodes. That means I have given a best example for human body, right? So so walking, for example, walking, your legs are the responsible things, right? So control plane, it will just manages, it will give the signal to the leg, you walk. So like that. So control, your application will not be running under control plane, rather your applications will be running under the worker nodes. So now we'll try to understand all four services: API server, scheduler, and cluster node, store, and controllers. First, what is this API server? So when you see API server, it is the first central station of the Kubernetes. All the communications between all the component must go through the API server only. So all the requests, everything, all the roads lead to the API server. The request will go from the API server. Then it exposes a RESTful API that you post. So you might be having a question how the request will go. So as a developer or any DevOps engineer, they will communicate to the your all your applications via the API server. So how they will communicate? Via HTTPS calls. So API server, it exposes an endpoint to the end users. So they will use all the request, they will send the request via HTTPS calls only. So whenever they are sending, they will send a request. How they will send a request? Again, as an YAML file. So that YAML file, we call it as a manifest file. So developer will send a request. For example, you run this application in this node, in this particular machine, via YAML file. So all the requests will go to the Kubernetes via YAML files only. So YAML file will have desired state of an application. This desired state includes things like which container, which ports to be used, how many replica sets. Say you are going to deploy your application into the Kubernetes via API server, you will send a request via YAML file. Using an YAML file, you will define there which container and which port you will define in the YAML file. So you use this port and you need this many replica sets. So what is this replica set means? It's a copies. When you are running your application or a container inside the server, you have to set like how many containers you need to create. That will useful for you to for the load balancing. So then what is this cluster store? So there is another main component of Kubernetes, that's a cluster store. As a name indicates, right, it will store the data. So all the information, whatever YAML file configurations, everything you are sending to the through the API server, and including the cluster information, everything will be stored under the cluster store component, and it is based on the etcd. etcd, what is etcd? It's a popular distributed database. It's a single source of cluster. All the backups are available in cluster store. You should run between 3 to 5 etcd replicas for high availability. So what we will do, the cluster store, in the cluster store we will also run many replica sets of the etcd. That is, it is just for a backup purpose. What is the scheduler? Whenever you are sending a request to the API server or a API service via YAML code, via YAML, so in that YAML or manifest file, you define the port number and how many container, that I know how many replica set. That information once you send to the API, server API, then what scheduler will do, it watches the API server for new work tasks. So what are the tasks, it will just observe what are the requests are coming. Based upon that request, what it will do behind the scene, it will filter the worker nodes. It will identify the worker node, you take this task and complete it. So how it backend, it will be, jobs will be running, any node incapable of running the task, it will be ignored. So it, what scheduler will do, there will be multiple worker nodes will be there. So that worker nodes, it will just see based upon the ranking, it will assign the ranking based upon the capacity of the worker node, whether the worker node can be taken the task or not. Based upon that, so any node incapable of running the task, it will be ignored. So what is the controllers? Controllers manager implements all the controller, deployment controller set, stateful set controller, replica set controller, etc. So uh, these are the very important controllers which we have in a controllers component. So stateful set controller, replica set. What is the main usage of the controllers means? Whenever, for example, you have one .NET application or microservices you are deploying into the Kubernetes, and you are saying you need 4 ports and the port number some 5035 something. So 4 containers you required, you mentioned in the YAML file, that is a that is in the manifest file. So what is that file? It means it is a desired state, right? Desired state is whatever, it's a required, what you are telling, I need 4 containers. Then uh, once you send request to the API, the scheduler, what it will do, it will send a request to the available worker nodes. Then maybe worker node, maybe it may be running instead of 4 containers which you requested, instead of 4 it might be running only 3. Now the desired state is not equal to observed state, so that information, it will just managed by these controllers. So we will see in detail of these replica sets, how we can create a replica sets and all, how it will compare with the desired state and observed state in the upcoming sessions. So all 4 services are the brains of the cluster where task scheduling decisions happen. So these all 4, whatever we discussed, API server, cluster store, scheduler and controllers, all these 4 services are a brains of the cluster where task scheduling decisions will happen. This is a brain. I have given a example of a human brain. So next, what we have, the worker nodes. The worker node is one of the best example of the worker node is human parts, right? So worker nodes, where user applications runs. So even how the control plane is having the 4 components, again here worker nodes also will have multiple components. What this worker nodes will do, it will watch the API server for new work assignment. See, already I explained, like API server is the main road for all the components. So worker node also, it will watch the API server for new work assignments. So it will execute the work assignments, whatever it is assigned from the API server and schedulers and controllers. It will just take the work and it will execute the work assignment and report back to the control plane via API server. So what are the components of worker node? We have kubelet, container runtime and kubeproxy. So where your application will be running. So kubelet is it's a runtime, it's an agent, it's a kubelet agent, we call it as a KTS agent, installs in every worker node. So that means wherever worker node is there, this kubelet will be there. One of the main job of kubelet is to watch the API server, whatever new work is task is assigned, it execute the task and send the response back to the controller. Container runtime, it will so earlier the Docker container will be using in the Kubernetes, but now recently K8s has native support to a plugin model called container runtime. So when you create when you package the image, or when you package the your application, and when you hand over to the Kubernetes will run your application inside a worker node by using the container runtime, that is CRI. We call it as a container runtime interface to run the application as a container. So then what is the kube proxy? This runs on every worker node and responsible for local cluster networking. So when you want to run your application, the networking is very important. So kube proxy, it ensures nodes gets unique IP address. It will make sure it will runs